Hey, so I went into editing this video and I realized that I filmed more than half an hour of videos with the microphone turned off, and right now my phone is in front of it, so it's also a problem. So I do have a lot of nothingness. As you can see, the commits are here, and yeah. So usually what I do when this kind of thing happens, I just drop all the commits and start all over. So what I'm gonna do is instead, I will show you the current state of the project. It's gonna be a little bit annoying because I made so many little changes that yeah, but anyway, you can always at any moment clone or fork the project. But let's start by looking at what the game looks like now. There's not much differences. I just added a new component at the top, which is the currencies view. And as you can see, we have now the data Pokédollar being displayed at two locations. So this one will go away somewhere because we don't need it anymore. And yeah, so the point of this episode was to create a second component, which is right there, the currency view. And the second point was to actually move the data objects, right? I'm gonna go on Obsidian to make a little drawing. Right, so this is very rough, but the idea is that we do have a main class, the main component, and the currencies component. But they both need a data object. So at the moment, it is main, which is creating the data and controlling it. And currencies basically need to get that data. So instead of having the main component controlling the data, what I did is create a parent object of both, which I named game. So the idea is that we have a game object now, which has one data object, and anyone gets to plug on this data object here because everyone has access to game. That's the point, right? We have this new node here, which is the game node. So the game node is on my projects, the master node, the first node that is launched by the game when you start it. You can choose this by going in the project settings, into run, and yeah, choose the main scene here. Once this is defined, what I did is create a user interface node where I just created a simple VBox container to organize my currency view and my main view. So the VBox here is anchored to the top, and yeah, actually I don't need to say this. I changed the theme override constant separation, right, to have a little bit more spacing between the currencies and the main view. Those two objects here, they're just drag and dropped in there like this, right? In the currency view, what I did is a very simple thing. I made a VBox here. I made a top border with the label in it. And here we have a margin container. For the content, it's a margin. Well, I just wanted to have 32 pixels on each side. It's not necessary, it's just like, well, anyway. We have the label here and a very simple script. In the script, we grab the label and we grab already the reference of the game. So I will come back to this after I explain the game node. In order to update the label, what I did basically is use the update the label every frame. So it's definitely not the best way to do that. The best way to do that kind of labels is to use signals. But in order to make those signals, and based on the planning that I have for this series, I will want to have basically a resource manager. And at the moment, the resource manager doesn't exist, so it's not possible to have access to the signal yet. So because the signal doesn't exist, what I did is the messiest way, but also the cheapest and simplest way. I asked the label to basically check and update itself every frame. When you have one label doing it, it's fine. But when you have like 100 labels doing that every frame, maybe it's a little bit too much. I don't know. Our computers are good, but every little prompt you can get is always good. So anyway, what happened in this game thing? Alright, so I gave it a very simple class named game, and I did this little part here. So if you've seen the starter series, you already know what this is. If you're new here, this is a singleton pattern. So on Godot, I know very well that people do use Autoloads as substitutes to singleton because there's the global access to it. However, Autoloads are not singletons, right? You can make them being singletons, but they are not. They do have their advantages, like I have no doubt about this, but at the moment my brain still didn't compute how those autoloads are good, right? Like it's just the same as singleton, but I don't like their wide aspects. So here, how you make a singleton basically is you create a static variable. So what a static variable is, it is a variable that you can access by reaching the class name, basically. So usually when you have a class, each instance of the class is individuated. So each one should have its own reference. But you can make methods or variables to be static. And when you say that, you mean all the instances of game will share the same method or the same variable. Here, reference. So here, the reference variable is quite literally a reference to a game object. So when you access the game class and access the static variable ref, you get a reference to one of the game instances. So another way to name this is instance. But instance, it's a very long word. So yeah, ref is way shorter and it's saving a lot of space. So what we do basically is that when we create this node, we actually check if reference is empty or not. If it is not empty, which is basically if ref, we actually don't want to override the game objects which already took the slot. So what we use is the queue_free method to say, okay, I arrived in, I asked to see if there's already a game in the room. There is a game in the room, so I don't get in and I leave. All right? But if there is no game and the slot is empty, then I will take it, which is this thing of the reference being I'm giving myself as the reference. So the result of this is that anywhere in the code, you can say game.ref, and you actually have access to this class now, to the instance of this node, by saying game.ref anywhere. All right. What we have next is two variables, which are the user interface scene, which comes in the form of a packed scene, and the data that we initialize. So yeah, here we import the packed scene, which is basically drag and drop like this. Nothing big here. The reason why we want to do this is because here, look at the user interface. I just drag and drop the scenes right in the trees, right there. Because it actually doesn't matter that user interface has to do things before the CurrencyView and the MainView appear. So it's probably not very clear. It will get clearer when we get to game, but it doesn't matter if they all arrived as one, or if user interface arrives and then bring in CurrencyView and then bring in MainView. It's not going to change anything. But here, in game, actually, there is a difference because we initialize the data. And if you actually look at the MainView here, in the ready method, all right, we update the label, we reset, we update the left HP, but in the reset and update Pokéclicker label, basically we will change the data. So it requires the data to already exist. But there's a problem. The problem being that when you instantiate a scene on Godot, basically the ready methods go from bottom to top. So if I look at the CurrencyView here, the ready methods will happen in this order. First you will have Pokédollar, then you will have content, then you will have reference rect, then label, then temp border, and then finally CurrencyView. So what this means is if you have the user interface right there, the ready function of the user interface or the MainView will be called before the game. So with the data and stuff and loading and etc., it can cause some problems. So what I do instead is I just add one layer of control, if you want to say it like this. Instead of just dragging and dropping the instance of the scene user interface in the game here, like instead of doing this, right? I delete it. I bring it in the code as a packed scene, which is exactly the thing that we drag and drop. And in the ready method, I do those two lines, which are I create a node by instantiating the packed scene, and then I add the node as a child. All right. The reason why we want to do this is because you can choose exactly at what moment you want to initialize it and plug it into the tree. All right. Yeah, I guess I didn't say much about this enter tree method, but yeah, the idea is that when we enter the tree, we really want to check that do we actually have a place there? Yes, no? And then we want to initialize the data. At the moment, it's a little bit weird, but the way that data instantiation is here is because what we will want to do is to have the load happen here. So yeah, in the main view, what we did basically is we changed this var data here to remove the new instance of data and instead grab the reference of the data object by using the reference of the game node. So here we have a single, we just grab the reference, right? So instead of saying game ref.data all the time, we just have this little data shortcut. It is very important to have this onReady tag above. It can be above or it can be right next to it. It's based on your preferences. This tag basically says that this line is pretty much shortcutting this, right? This is exactly the same result as having this onReady tag, right? The reason why we need to instantiate the data in the onReady, and we can't do it like this or this, is because it requires computing, and it actually requires the data from the game. And the data from the game doesn't exist when the node is floating in the void, sort of. When the node is floating in the void, it can compute very simple variables, strings, ints, or basically objects which are just scripts, but it can't interact with other objects. So at the moment you interact with other objects or the nodes in the game, you actually have to wait for the node to be added to the tree and added to the tree. So that's why we get this onReady. All right. Otherwise, once we have changed the reference of data, the rest of the code is exactly the same because we did use data before. We just changed, right? Instead of having data new, we have the reference, so it works fine. Okay. I'm thinking, did I forget anything? I don't think so. I think we're good. Yep. Well, it's gonna be 20 minutes. It's very fine then. I went over all the changes that happened in this episode when I was muted. So yeah, I hope you like this one. There's not much visual features to see, but it's actually quite an important episode because, there's a lot of refactoring and changing how data works and allowing basically different objects to access the same data. So yeah, it's a very important feature. Not visual, but definitely mechanical. So anyway, this is it for today, and I will see you in the next episode where we will be doing I have absolutely no idea what. So see you later and take care.